equation. We're still on homogeneous equation. Let's know if this equation is homogeneous before we solve it by substituting y equal to vx. Let's know if the equation is actually homogeneous. What's still having in mind the conditions for an equation to be homogeneous? We say that all the terms in the numerator and denominator must be of the same degree, must be of equal degree. So the degree of the first term here is 1, the degree of the term here is 1, and the degree of this term is also 1. When we say degree, we mean the exponent of the variable. So the variable here is only x, the exponent is 1, this is 1, and this is 1. So the degree all around, both in the numerator and of the denominator, are equal. Therefore, the equation is a homogeneous equation. So definitely we go by saying let y equal to vx, and definitely the y over the x is equal to v plus x dv over the x. So if you've not seen the previous example, that's the example 1 under homogeneous equation. If you go to example 1, you will know why we wrote this. Whenever y is equal to vx, differentiating this guy using product rule will give us that the y over the x is equal to this. So now this is the new value of the y over the x. And coming to the main equation, since the y over the x is v plus x dv over the x, we can remove the y over the x and replace it with this, so that we have v plus x dv over the x is equal to, coming to this side, we have x plus, anyway we see y now, we can now put vx, so we have 3y and then that's 3vx all over 2x. Alright, so we have v plus x dv over the x is equal to, you will factor out x, and here is 1 plus 3v all over 2x, which x takes away x, so that we have x dv over the x is equal to 1 plus 3v all over 2 minus plus v crossing to that side is minus v, or we have x dv over the x is equal to the LCM, we have 1 plus 3v, then 2 multiplied by that is minus 2v all over the common LCM is 2. So that this is x dv over the x is equal to 1. 3v minus 2v is actually v all over 2. Okay? So we can quickly cross multiply. We'll cross multiply, we have 2x dv is equal to 1 plus v all the x. So at this, with this now we can now separate the variable. Remember, when you cross multiply, having it like this in linear form, then to separate the variable, we have 1 plus v to come under here will give us 1 over 1 plus v dv. Or let's put it this way. Of course, there is a 2 here, so we can actually say 2 over 1 plus v. That's 2 here. Then dv equal to, then taking x out, putting it down here, we have 1 over x dx. So as you can see, well, we have to maintain these 2 here while we take 1 plus v under here. Then taking out x to go under here, we have the variable separated neatly. Okay, the next is to integrate both sides. Integrate both sides. So 2 is a constant, we have our 2. And then of course, this is something as saying 2 integral of 1 over 1 plus v dv. Just to verify some persons that won't actually get what we're doing. So now 2 is constant. To take it out, we're now integrating 1 over 1 plus v. then you find out that it is evident that the differentiation of this denominator will give us 1, because differentiating 1 is 0, differentiating v is equal to 1, and then 1 is the numerator. Therefore, we have 2 multiplied by the integral of this becomes ln 1 plus v equal to integral of 1 over x is ln x plus ln c. This c I can equally say ln a, or anyone who choose to use, I can say ln x plus ln a, where a is still the same constants we're talking about. Alright, so we have 2 ln 1 plus v is equal to, of course, taking one of the logarithm, take one of the ln, and multiply the number, we have ax. Then this 2 actually is a coefficient. So as a coefficient, we can actually take it up according to one of the laws of logarithm. We have ln 1 plus v all squared. It's back to the front. Take the 2 back to the front. We have this and equal to ln ax. Okay, then we can take the logarithm out from both sides. The ln will cancel out the ln, so that we have 1 plus v all squared is equal to ax. Then recall that our y is equal to vx, and of course v is equal to y over x, so that v is equal to y over x. So we have to substitute here 1 plus y over x all squared is equal to ax, right? We have find the LCM here. We have x plus y all over x all squared is equal to ax. Right? So the power here is affecting both the numerator and the denominator, of which we're going to have x plus y all square, of course all over x squared is equal to ax. Right? Okay. We have finally here, our answer will be x plus y all squared, and then we cross multiply. X squared multiplied by ax will give us equal to ax cubed. Eventually, this becomes the final answer. Thank you and God bless you.